Welcome, pilgrims, to part 3 of the WTP, the wee tiny Phoenix. This segment shows the construction of the flight computer. I am still waiting for the local weather to allow either a club lunch or for the farm to green up. When, and dare I say, if it ever happens, I will do the test flight of the WTP with either an Aerotech F-35 or a 2-inch PVC rocket motor, depending on which launch location cooperates first. Being sick with the crud for the last 3 weeks, I have been forced to stay out the cold north wind. My intentions are to go on a hunting safari to hunt down and bring to justice that lying groundhog. Early spring, bah humbug. The flight computer is an essential part of the WTP. It is responsible for controlling the rocket's flight and ensuring a safe and successful launch. To construct the flight computer, I first started gathering all the necessary materials. This included a microcontroller, sensors, and electronic components. I then began assembling the circuit on a printed circuit board, making sure to follow the schematic and double-checking all connections. Next, I programmed the microcontroller with the necessary code for the flight computer to function. This included coding for altitude readings, as well as drogue and main parachute deployment. Once the circuit was complete and the code was uploaded, I tested the flight computer to make sure all functions were working properly. After several successful tests, I mounted the flight computer inside the rocket and prepared for the test launch. Unfortunately, due to weather conditions and my illness, the launch had to be postponed. But I am eagerly awaiting the opportunity to finally test the WTP with its new flight computer. Thank you for following along on this journey, and I hope to have a successful launch video to share with you all soon. Until then, happy rocketeering, and may the winds be in your favor.
Alrighty then, we got to intro it. Pretty neat little video clip. We're starting the construction now, and the breadboard there is just a basic test jig. It's not got all the components on it. It's just to test the IC2 channels to the barometric sensor and the chip itself. And what I'm doing now is installing the headers for the D1 module. And so I get the spacing exactly right. Long end down, short end up. And the D1 has to be with a USB on the bottom and the silver chip up on top. You put it in the other way, it'll fit just fine, but it would not work on the circuit board. The circuit board is designed for it to be in that orientation. So now what we got to do is go through and solder all those little pins. And while I'm doing this, I'm constantly fighting with this light and the camera and the soldering iron getting wrapped around it. And then because of the way that the camera's on the right and I'm right-handed, I keep my hand in front of what I'm doing, but we do some close-up work of it. It's a pretty basic soldering, very fine soldering tip, very fine solder, so that you just get the correct amount of solder on each pin, but each pin is very securely soldered. One thing you don't want is cold solder joints in anything you ever build, but especially this, a cold solder joint could lead to a destructive rocket or a parachute not open. And even though I've got over this cold a little bit, it's still hanging on, so I'm a little bit hoarse this morning. Maybe not quite a horse, but a pony. Anyway, so we're soldering those pins, just going down the line and soldered them. And we'll switch over to a different view where you can see past my right hand there. And I got one side soldered, so I'm going to start down the other one now. I find it a lot easier to do the pins while it's mounted on a breadboard. And everything is very stable, other than the breadboard wants to slide around a little bit. And this is just to, we would go to the computer once this is done and energize this through the USB port and make sure that the two chips are talking to each other before we put them on the circuit board. Now here you get a better view of what I'm doing with my hand there. Is just a little bit of solder on each one of them, make sure they're not bridged, make sure that they're not a cold solder joint, fairly hot iron with a very small tip. Yeah, you can't use a big plumber's solder with acid flux and a 1/4 inch tip on it. It'd be a total disaster. So you see there's two D1s on here. One of them's just already doing the test for the barometric sensor, but before I test it, I'll switch out to the one I just soldered. And I got an extra barometric sensor there in the front that's not being used. Again, this is just a pre-test of the two components to make sure that they're communicating properly before they're committed to a printed circuit card. And while they could be removed without the proper equipment to do it right, it's very hard to do. I got a heat gun that blows temperature sufficient to melt solder. It's an SMT removal tool. But that D1 board is a fairly significant heat sink and it makes it really hard to get off. I think I tried it once and I gave up on it. It's easier just to chunk the circuit card and start over. So this step is important to make sure that when they're on the board that they will be operating correctly. Of course, the board's been designed for these components, the 5K and the 10K resistors. That's the only two value resistors that's on the board. And then everything is handled. We got I mentioned it before, but a safety jumper that acts like an external switch. You can jump it to make it always on, or you can put an external switch where you can turn it on at the last second while the rocket's already on the launch rail and nobody's standing over the top of it. What I'm doing now is doing the same thing with a little barometric sensor. And I think it's got 8 pins on here. It's very easy to do. The only problem I've had with it is that it wants to not be parallel to the pins, or not parallel, but 90 degrees to the pins. It wants to droop down. So what I'll do is I'll tack one and then use my finger and push it up to the correct orientation, just so it looks right. It would work, droop down, no big deal, but it don't look very professional. So I bring it up on that one pin and then I solder the other pins to the board. Again, using the breadboard only as a correct pin spacer. Those pins are not individual, they're a strip, so when I say pin spacing, I don't mean the distance between the pins. That's set by the strip connector and the board itself. And I'm more talking about like the bigger chip where that the correct spacing is across the breadboard, left to right. So we got that little devil soldered now, and we're going to take it out and substitute the one that's already on the board with this one. I actually got 2 breadboards, one for soldering and one for testing. And I want to energize it with a battery for this particular test. I will just let the USB port power it. Again, we're just confirming that the IC2 bus is working correctly. Well, look like we're ready to go over and test it now. We don't show that particular test, but basically it's bring up the web page and make sure that it's reading the altitude and that the chip is talking correctly. The firmware has already been loaded onto the chip at this point. Actually, initially, that's about the first thing I do to it. And here I got the schematic and the individual components. You see the two channel FETs there, one for the drogue and one for the main. And all those other items laying there are resistors, 5K and 10K. And so I pull out my schematic that I designed it by and make sure that I'm getting the correct resistor in the correct place. And I think there's maybe 10 resistors, 8 resistors, I don't remember right offhand. I'm doing this much later than when this video was made. Now this little device here, anybody's ever seen those, they know what it is. It's just to hold a board, and the clothespin is on there holding the IC chip up on the boards. And again, the orientation is with the USB down and the silver can up. So we're getting ready to solder those two components or two items to the board. And once they're soldered on there, like I said earlier, they're pretty much committed. So again, very thin solder, very fine tip soldering iron. And again, I'm fighting two cameras and the soldering iron that keeps getting wrapped around the lamp. I think at some point if I just give up and stop the video and start again, I may be already past that point. So we just move down the board, solder each one of those. And what's happening now as I press the solder down on the joint is that holder is light and it's dipping down, which makes it really unstable as I'm soldering. So I add a little bit of weight, and then eventually you'll see me just give up and put the clamp on it. And I still see the board deflecting just a little bit. And once you get a few of these on there, the clothespin can be removed because you already got the chip seated. But it's not in the way right now. It's not causing me any problem. I'll just leave it on there for now. But actually, if you solder one at the two opposing angle or corners, it would be secure enough that you wouldn't need anything holding it on there. A little bit of solder, a good hot soldering iron, and quickly soldered. I've not had a pad pull off this board. Those people do a really good job of building the board. I've never seen a pad pull loose. I hate a PC board that the pads pull loose on it. So I'll give a good shout out to my buddy over at Rotary Rocketry channel. And I did the UI, user interface, initially. And then George looked at it and he said that he could do a much better job, and he did. He did an outstanding job on it. So it's basically me doing the hardware and the printed circuit board and the initial build and check, the one you see him test on his website over there, or his channel. And then him and I collaborated on finishing up the UI and some other tweaks that we made for the altitude detection. And I came back after him. We kind of split directions at that point. He headed off in one direction to finish the one he was designing. And I took what we had done, and I actually just rewrote the entire logic for the flight. Had worked around it and found a cumbersome way to do it that was not exactly working right. It was on a slow rocket, like one of these that you've seen on here, one of the BT-70 style size rockets with a E12-0. It's a slow ascent, and the flight computer was misinterpreting where the apogee was. It was doing it early. And then it got into the thing where it would be either early or late. And so I said, I'd kind of come into it backwards because I've tried so many different things, and I looked at it in a holistic view and just came up with one detection method that worked really well. And I'm anxious to try it again. I flew it a little bit before the grass turned brown here. And winter set in, and that kind of ended the flying season for me on the farm. So like I mentioned in the intro, waiting for the grass to green up, and we've had 2 club lunches canceled. Then I modified the rocket to be able to use a commercial engine at the club lunch, and we'll be flying a PBC one here most likely. And the reason I'll be doing that is that's what the rocket was ultimately designed for. The wee tiny Phoenix that this series is referencing. But I don't want to fly a commercial case here because of the fact that it's so easy, very easy to wind up in the top of a tree. And I'm not talking about a 15, 20 foot tree, I'm talking about one that's 50, 55 foot. And it's just a total loss when that happens. I also had a problem with a short lunch rod, which I haven't been able to try the new one. I extended it out from 6 foot to a little bit over 10, and rebuilt the base so it is more stable. So hopefully we'll get some good vertical launches this year out of it. So here I've got the chip on there. I've still got the clothespin on it. And I'm having trouble with this camera being in the way, the one that does the close-up work. And of course the LCD on that camera is facing away from me, so I just kind of have to estimate what it's looking at. Sometimes I get it, sometimes I don't. Now we got the chip on there, I believe I've been talking, not really paying attention, but I think we got the chip on there all the way around. A little bit of adjustment, and use a magnifying glass so I can see the fine work. Took the clothespin off, and yeah, we'll see the orientation here hopefully. Still working upside down, so there's something I'm still attaching to the board on the top end. This is the bottom side of the board. And a lot of this back and forth between the cameras, one thing gets behind the other one and they're not completely in sequence. So you're jumping forward and backward in time, depending on which camera you're looking at. They're all relative, but they're... Now here I am going down the outside line of the pins. Okay, maybe we're going to flip the thing over now, I hope. No, we're cutting off some long leads on the PC chip. And that's a side cutter. That was on the barometric sensor. So you see the proper orientation on that. That would be with a USB down, the silver can on the D1 and the antenna up, and on the barometric sensor 280, it would be the little silver can, which is the actual sensor, would be up. It don't matter where they're up or down, it's not even bearing on it, other than the circuit card designed for it to be up, and so therefore it has to be up to get the pins right on the power and the IC2 channel. And here I am messing with these resistors, getting ready to put them in. Kind of a tedious job. I got one resistor that is going to have to be relocated. It's not really in the way, but it could be out of the way a little better. So it will require a Another redesign on the circuit board, just moving something around a little bit. And the circuit is very simple, very hard and fast. It's just basic 5-volt logic. It's actually running on 3.7 because the battery is a one cell 3.7, somewhere between 5 and 800 milliamp hours, which 800 milliamp hours with the draw that this board draws would run all day long on it easily. 300 might be not quite long enough. It would need to be turned off. But normally these are, for me, they're one plot and I'm through with it. And the chip does power down at the end of the plot. Or the board powers down. It's actually the chip goes to sleep. And so I don't refly it again because it would require reloading the injection charges out in the field, and it's a lot easier to do it in the shop than it is out in the wild, dealing with the igniters and black powder and containers and all that stuff, and then repacking the parachutes, which it could be done easily, you know. Just I'm lazy, I guess. I'm definitely a person that will take the path of lethal resistance. And you see that cussed jig is dipping down every time I solder. And that just aggravates the hound out of me. The thing needs to weigh about 4 times what it weighs to be able to support a board. So like I say, at some point I just give up and put a clamp on it, which is probably should have done from the get-go. And here we got the long lead sticking through, and I will actually use one of those as the switch because I leave mine energized all the time. I don't put an external switch on it. But I make very sure that I'm not over the rocket when that is energized. Because I got an aversion to having a nose cone stuck in my eye. And really the power charge on these is not enough to drive that blended nose cone and actually do any real damage, but you know, it always could, so you just have to practice safety and make sure that you're never standing directly over the nose cone when this thing is powered up. And I found out in all kind of aspects of my life, if it can happen, it will. Things you wouldn't even think about happening, and that's how an accident really occurs, is you're not seeing the whole picture beforehand. And then something reaches out and grabs you. Like driving down the road too fast, you know, you're not seeing without your seatbelt on, you're just not seeing the total consequence of what could happen. 9.5 times out of 10, nothing ever happens, but that's not a reason to be a risk taker when your life is on the line or your vision. I'm not an adrenaline junkie. No cave diving. Can't stand cave diving. It's hard for me to watch on TV. A lot of cave divers have been killed over the years from nitrogen narcosis to getting trapped to being stupid and going into something that you can't back out of. I just don't know how I got off on that. We just watched a movie not too long ago about cave diving, and I fell in a pond by accident when I was about 7. Didn't know how to swim. The bank caved off underneath me. I went in head first and came very close to drowning. Now I swim, and I'm a decent swimmer. I mean, if I fell out of a boat, I could swim back to the boat, or if it was close by, I could swim to the shore. But back then, I didn't know anything except beat the water and scream, and that stopped going to get you out of a drowning situation. So some of my friends might say I suffered a little brain damage, but otherwise he's all right. Oh man, that would be some of my friends what they would say. No, thank God I got out and didn't drown. I'm saved by a piece of barbed wire hanging down in the water. And my wife went whitewater rafting many years ago, and I was sitting up on the edge of the boat close to the front. It was the first time, it was early in the season, the first time the guide had been down the river other than to practice. I guess maybe with some of the first ones he'd carried on his trip down. And we come through a rapid, and there was a rock, big old giant rock, about the size of a Volkswagen bug. And that raft run right into it sideways, and the rim I was sitting on, I'm just looking at some of the solder joints here. It caved in underneath me, and I went out backwards, upside down, under the boat, and came out in really cold water, headed into a class 3 rapids. And then I started hyperventilating, uncontrollably hyperventilating. It was keeping me from swimming because I couldn't ever get my breath. And of course they were trying to turn the boat sideways and let me catch up to it, but I had to stop hyperventilating before I started swimming. And I finally got to the boat, and the guy grabbed me by the suspenders or the straps or whatever and pulled me right up on top of it. And we were laying face to face in that boat, and he said, "If you ever tell anybody about this, I'll deny it." And I thought, well, I will too. But the guy did a good job getting me out of the water. So I had to get over on the rim and re-weld to the boat. And I welded so hard to the boat that we was headed into that next class 3, I think it was. I welded so hard to the boat that when it come time to get out of it at the end of the trip, I almost couldn't get out of it. But I was going to make absolutely 100% sure I didn't fall out the next rock we hit. It was a fun trip. And they say it was a fun trip until I fell out the boat. Well, I've filled up the space here with unrelated stories. And I'm still installing resistors on there. I do them in kind of a group of 3 or 4 so the leads are not in the way when I'm soldering. It's amazing how that quickly 2 cores can get entangled, the string therapy or quantum physics. There ain't no miracle that things become entangled. I believe you can take 2 pieces of wire and lay them out in a 40-acre field, and then somehow they'd find a way to get wrapped around each other. And the reason I mention that is because that's kind of what's happening with the soldering iron here. Trying to work around that lamp and the magnifier and the camera and the other camera and the little holder. And that looks like the last set of resistors pushed through there. You can see over here in the background my glasses laying next to that. That white object is about an 800 milliamp hour battery. The one laying beside it's a 3 or a 500. And either one of them will work. They're single cell light poles. So all the building of this thing is just, basically repetition. Put the component in, solder the wire, move on to the next one. You'd think I'd built so many of these that I'd be able to do it without the schematic laying in front of me, but I don't remember which resistor goes in what hole. It's R1, what's the value? It's not on the board, and maybe that needs to be on the board for each resistor. On the silk screen part of the board. And I think I'll switch over to some music at this point. I don't know there's a whole lot more that I could say about what's going on without starting to just absolutely repeat myself. So we'll do music for the next segment till we get to the actual test where it's put together and we're going to test it. get the power leads on there using the clothespin to hold the wires in place. And I'm still fighting with this thing. You know, I shouldn't have fixed that way back instead of just keep trying to find something heavy to lay on the back of it. Oh well, it's easy to be an armature coach, ain't it? Anyway, I get those two wires soldered. Being careful to make sure that they're proper connection, positive where the positive goes, negative where the negative goes. There's no protection on the board for reverse polarity, so I don't know what would happen, if anything. I looked at the board and I wasn't happy with that one chip pin. Looked like there's a little, had a void in it, so we heaved it. So now all really we got left to do to put on it is the FETs and the connector block. Look, I went and dropped that, didn't I? So I stick these FETs in there and I kind of spraddle the legs out a little bit to hold them in place when the board is turned upside down to solder it. Just a little bit of friction, otherwise they'll fall out. They'll come out just as easy as they went in if the legs are straight. Not legs, leads, what I call legs. And I think I will solder half of them and then clip them and then solder the other half because they are basically in the way of each other. To me, that's more of a cumbersome soldering than the rest of the board right there. Those pads are pretty close together and it's easy to create a bridge if you're not careful. But just checking to see if we're recording. I hope we are. Looks like we might be. And get that camera out of the way. You don't want to stand up. So now we got the last item I see laying over there on the schematic is the connector block. You got a common, a drogue, and a main connection point. I'm going back and clipping off the FET leads. On that connector block, I found that the easiest way to do it is to put it on there and then hold it up against the board with my finger. And that way it don't come out really wonka looking. Otherwise you can raise 1 inch, one side. Alright, we'll go back to a little bit of music and then come back on a record. can see the beastie all completed there. All the solder joints. And you see the silver can on the biometric or altitude sensor. Lost my train of thought there for a minute. It's getting uncommon. Now what I'm doing now is connecting the test lights. It's 2 Christmas tree little tiny lights. Come on a string of Christmas tree lights. And they work real good for testing at 3.7. 3.7 not enough to burn them out, but it's enough to light them. And so that's the way I verify each channel is working, is by putting those bulbs on there. There are 2 leads to the common and 1 each to the other 2 channels. So what I'm doing now is tightening down the screws where it's fastened to it. And then get rid of some of the cut-off leads before they wind up attaching themselves to the board. And we're going to put a battery on it and power it up. And one check here is to make sure that neither one of those lights light when the battery is connected. That would be a fail, because it would set off the charge as soon as you plug the battery in. So there's a couple things that we're looking for, and that's the first thing I'm looking for, is that nobody lights on the initial battery connection. The little blue light blinking is that the CPU is running instead of in a locked up state. And now we're going to go over to the PC, and I will show the screen on the test that we run, but it's basically energize each channel separately and make sure that the little Christmas tree lights. Gotta have computer glasses. Can't do it without being able to see. And so hopefully we'll see these light one after the other one. What I'm doing now is connecting to the device through changing the web page to connect to the wireless network that the device is providing. Each one of them is unique. The SID is unique thanks to, again, to George and his programming. And we'll see, hopefully soon here, one or the other light and then the other one light. Also, the other test that I run is that now it should show both igniters connected, but if we unconnect one at a time, you would see that channel go inactive, not be able to be used. And for a single deploy, it don't really matter that the drogue is not connected. Obviously, there's no drogue, so the normal state of affairs would be not connected. But when it's dual deploy, it checks both igniters to make sure they're not an open circuit. And we're going to shorten this down to where the light comes on here. Alright, well then we went cut it right at the point that the light came on. So we're still dribble talking. There's one channel, second time, third time, one time, 2 times, 3 times. And that just verifies that the FETs are able to be energized by the computer, onboard computer, and that the connector that connects the igniters is properly wired and operating correctly. And that's pretty much the end of the testing on that we can do. I'm also looking at making sure that the 2 chips are still talking to each other. But we'll jump. Okay, well, one last thing we got to do is I check out the battery charger for the battery. And that's a single cell USB powered battery charger for LiPo. And you can see the little LED that shows it's connected and charging. Real simple device. It's pre-made. It's not anything that I've made. I mean, I soldered the wires on it, but I didn't make the board or use the components on the board. The next thing we're going to do is jump over to the PC and just go through what I was looking at as I tested the board the last time, verify that everything worked correctly, which it did, as you saw. And now we're looking over on the PC and we're looking for the network that this device is providing. We're going to connect to it. It's the same thing as connecting to your router in your house. So here you can see this Danny Prince Fleet is a text that you can change to whatever. The name of the device is DDD Flight Computer. And it's set up to the ejection modes now is a drogue deploys at apogee and the main deploys at set altitude, which is a dual deploy. Current ground levels 839 AGL and not 839 AGL, 839 above sea level, which is what the elevation is here where we live. And it shows that the drogue and the main are both connected with a green text and a check mark. The device is in the safe mode at this point. And we have to arm it to be able to test those two igniters where you saw the light come on. Now I went and disconnected them both at the same time, and it's showing that there's no drogue igniter and there's no main igniter. So actually would not let you fly in that condition. And they're back, connected again. We're still in the dual deploy mode. And the next thing we should do is arm the device. This is all done on a cell phone or a tablet or whatever you got that's got Wi-Fi out in the field with you. It records the last 5 flights and keeps a record of what the altitude was, the max altitude. So we're going to go into test, and we're going to test the barometric sensor, and it shows that AGL is 0, the temperature is 75 degrees Fahrenheit. And the lock ground level is 839. That's just reference for everything above 839 will be AGL after that. So we're going to go back to test mode, and now we're going to test igniters, which cause the light to come on. And it's showing that the 2 igniters are connected, and you have to type in the word test to be able to test it. And it looks like the first one we're going to test is the drogue, and we'll test the main. But you don't see anything happen on the screen, but that's when the lights were lighting when we test it. It fires the igniter for 1 second and then turns itself back off. So now we have tested both of those, and recording this after the fact, I'm not sure. I'm just kind of going along with you guys as you see it, because I don't remember exactly what I did at this point. And I was wrong about having to be armed. It's not armed. Now it's armed, which shows that the safe is white, the armed is red, the little slide button is red, the deployment is a dual deploy, and the altitude for the main is 200 feet AGL. You know, I've tried recording the audio on these computer screens as I do them, which is so much easier than coming in behind and have to, you know, either anticipate or figure out what I'm doing at that particular point. But the trouble is the audio will not stay synced with the video, and that's a nightmare to edit. It's next to impossible to get them resynced after the fact. because it's not one simple time slippage. It slips in the middle and then resyncs towards the end. And I worked on that and I have not figured out what it's doing exactly yet. So it's easier just to re-record it. This is the info chip ID, which is like a MAC number or serial number of the chip. The firmware version is my latest change to it. And again, the hardware design is by me and the firmware is by me and George. George, really associate George first because he really did an outstanding job on it. And then the SSID is the network it's going to provide, which is part of that MAC number with DDD in front of it. And the only time you'll see that on your cell phone is a viable network is when the thing's energized. Then we got our 2 channels on the YouTube. And then this is where you would change the name. You can change it to whatever, Mickey Mouse's Moonship, whatever you want to write. You can also change the SSID to something that means something to you. And you can put a network password on there if you're worried about somebody else messing with your rocket at a club launch. And now this one is a single ejection. And it's recorded the last 5 flights, which this is a new device that don't have any history to record. And during the process, I come up with a way to record the altitude at each. What you're going to see, I'll just stop here for a second. The altitude, the record altitude, the apogee, and when the 2 chutes were deployed. Well, since it hadn't flown, there's no data in there, it's all zeros, but there's 2 numbers in each column below the writing. One of them is altitude, and the next number is how many milliseconds it stayed at that altitude. And then the device has a test mode where I can play that back like a recording back to the device, take a real flight and then play it back to the device for troubleshooting or tweaking or just to see how it reacted, change some of the values, maybe make it stay at an altitude a little longer and see if it's going to do a false deploy. And so this is basically a troubleshooting, but you can also plot a chart off of it on Excel because you got the two items, the altitude, AGL, and the time it stayed there, so that makes a very neat looking graph. And that goes all the way through the parachute deployments all the way back to 50 foot above the ground. At 50 foot above the ground, the computer goes to sleep, turns itself off, and that's for the prevention that it got hung in the top of a 50-foot tree and would run till the battery just was destroyed. Or, it's not good to run LiPos all the way to 0, obviously. Everybody's touching LiPo knows that. And so as a safety precaution and to keep from having to see that on the network all the time, it turns off at 50 foot above the ground. And when I say turn off, it goes, the chip goes, the internet goes to sleep, and then the chip goes to sleep. It's still actually powered on, but it's, as I say, even the lights are not on and there's nobody at home, so it's a dead device at that point. So that kind of covers what the user interface is about and how to use some of it. It's just, I think, a really neat device, and again, for the 3rd time, George over Rotary Rocketry did an outstanding job on the user interface. And this is a test of the ability to OTA, over-the-air upgrade. So if there's a new firmware that comes out, you can use that to download it onto the chip. A little tidbit about the jump again here, just running through different levels on it. See the ground level jumped up to 107, which is the true altitude here on top of the mountain. Well, I think we'll end the video here. Thank you guys for looking. Hopefully you enjoyed it. And the next video and the last part of this will be an actual flight, either here on the farm or at a club launch. So take care, and we'll see you later.